Good morning. Today I am going to explain you some problems based on elements of factors in JEE main level and NEET level. See here, the first problem is, here A bar is given as 3i minus 4j and B bar is given as minus I minus 4j. Find the direction of A bar plus B bar. So I am writing A bar plus B bar is equal to, A bar is given as 3i minus 4j and B bar is given as minus I minus 4j. So A bar plus B bar becomes 2i minus 8j. So angle made, actually here it will be like this. This is plus I bar along positive x-axis. This is minus I bar. This is j bar along positive x-axis minus j bar along negative y-axis. So 2i minus j minus 8j, it will be in which quadrant? I is positive, j is negative. So it will be in the fourth quadrant. It will be like this. Okay. So here I component is 2 and j component is 8 along negative y-axis. So here angle made by this will be with positive x-axis clockwise, isn't it? So it is tan inverse, opposite side is 8, adjacent side is 2, 8 by 2 is 4. So tan inverse 4 with positive x-axis. You just look here, these two options are eliminated. So with positive x-axis, this is clockwise direction. This option is also eliminated. So the correct option is tan inverse 4 with positive x-axis in clockwise direction. Okay. So first we found the sum of the two vectors, 2i minus 8j, and it is in the fourth quadrant, I positive, j negative. So here with x-axis it is in the clockwise direction. So as the options are given in tan inverse, it is tan inverse, opposite side is 8, adjacent side is 2, opposite by adjacent 8 by 2 is 4. Tan inverse 4 with positive x-axis in clockwise direction. That is the answer. That is your first problem. Now go to the next problem. Look here. So let us look into this problem. Second problem. Maximum and minimum magnitudes of resultant of two vectors of magnitudes p and q are found to be in the ratio 3:1. Which of the following relations is true? Okay, so here read the problem carefully. Maximum and minimum magnitudes of the resultant. Resultant is p bar plus q bar. Resultant of two vectors p bar and q bar is p bar plus q bar, and the magnitude of the resultant is given by root of p square plus q square plus 2pq cos theta. From this, if theta is 0, resultant is maximum, that is p plus q. If theta is 180 degrees, cos 180 becomes minus 1. So the minimum possible resultant is p minus q. That we know it pretty much well from parallelogram law of factors. So directly we can go to this. In this problem, the p plus q and p minus q are in the ratio 3:1. Suppose if we take this as 3x, p minus q becomes x, so that p plus q by p minus q is in the ratio 3:1. So if you just add this, 2p is equal to 4x, from which p is equal to 2x. P is equal to 2x. And here if you substitute that value of p as 2x here, q will be equal to x. Q will be equal to x. So, from this expression, it's very clear P is equal to 2Q. That is the relation between P and Q. So, the first option is correct for that problem. Maximum and minimum magnitudes are in the ratio 3:1. Maximum magnitude is P plus Q. Minimum possible magnitude of the two vectors is P minus Q, that is X. So, from this expression on adding these two equations, 2P is 4X from which P is 2X. And substituting that value over here, Q is equal to X. So, P is equal to 2Q is the right option for that problem. Now, let us move on to the third question. See here, read that third question meanwhile. See, the resultant of two equal forces is given as 141.4 newtons when they are at mutually perpendicular. So, two equal forces at right angles resultant is 141.4 Newton. When they are inclined at an angle 120, find the resultant. Actually, from the parallelogram law of vectors, we know R is equal to root of P square plus Q square plus 2PQ cos theta. If P is equal to Q, if two vectors are of same magnitude inclined at an angle theta, then if you substitute P in place of Q, then you will be getting R as 2P cos theta by 2. This is a very important formula we learnt during our synopsis. So, when two vectors of same magnitude P each are at an angle theta, the magnitude of their resultant is given by 2P cos theta by 2. So, here we start with that concept. Two equal vectors when they are at right angles. When they are at right angles, theta is equal to 90 degrees. That implies R is equal to 2P cos 90 by 2 is cos 45. Cos 45 is 1 by root 2. So, root 2P. So, two vectors of same magnitude P each are at an angle 90 degrees, resultant is root 2P. So, here it is mentioned that those two equal vectors when at right angles, resultant magnitude is 141.4 Newton. So, from this P is equal to 141.4 by root 2, that is 1.414, gets cancelled 100 times. So, P is equal to 100 Newton. Actually, Q is also equal to 100 Newton because they are equal in magnitude. Now, if they are inclined at 120 degrees, what is their resultant? Now, from the same expression, if the two are at 120, resultant becomes 2P cos 120 by 2. This is 2P cos 60. Cos 60 is 1 by 2. So, just it becomes P. But P is equal to 100 newtons. Already we found that value. So, the answer for that problem is 100 Newton. So, actually, if you are thorough with the concepts and if you are thorough with the table already given in your synopsis, that problem you can just answer that orally. Resultant of two equal forces when mutually perpendicular is a root 2P, that is 141.4. So, P is equal to 100. When two vectors of same magnitude are at 120, resultant is equal to one of them. So, at 120, as resultant is equal to one of them, resultant is just equal to 100 Newton. Actually, you must have that, you must be that fast while solving the NEET paper, because in NEET you have to answer 45 questions in 1 hour. Okay, so definitely if you have that in your mind, the problem is done within 2-3 seconds after reading, right? Now, let us go to the next problem. See here, magnitudes of two vectors differ by 1. The magnitude of their resultant makes an angle tan inverse 3 by 4 with P, angle between P and Q. Magnitude of two vectors P and Q differ by 1. That is P minus Q is equal to 1. That is one statement given. Magnitude of their resultant makes an angle tan inverse 3 by 4 with P. So, here suppose tan alpha is equal to Q sin theta by P plus Q cos theta. Here they have given that as 3 by 4. Tan alpha is given as 3 by 4. Tan inverse 3 by 4 is alpha. So, tan alpha is 3 by 4. That is equal to Q sin theta by P plus Q cos theta. So, simply I can say by solving those two we can find out the angle between them. But the problem is, if you look at these two, you have three unknowns P, Q and theta, but two equations. So, if you have three unknowns, two equations, it is not possible. Simply by substituting the values we can say. See here, with your common sense you can say this one, because tan inverse, if theta is 90 degrees, what happens? Sin theta becomes equal to 1 as cos 90 is equal to 0. So, simply Q by P is equal to 3 by 4. If Q is 3, P is 4, then P minus Q is also equal to 1. So, the simplest way of solving that problem is just you can substitute the options, you can verify from the options, but if you have that in mind, tan inverse 3 by 4 is 37 degrees if P and Q are at right angles. So, if that comes to your mind, it is very simple. So, that is the shortcut method for this question number 3 or 4, whatever. Next, this question. Look here. P bar minus Q bar is equal to R bar. P is equal to Q is equal to R. Ratio of angles between different vectors are given there. So, look here. P bar minus Q bar is equal to R bar. P is equal to Q is equal to R. All of them are of same magnitude and the difference is equal to R bar. So, the ratio of angles between P bar, R bar, P bar and R bar and P bar and Q bar. Say here, from this, what can we say from this? You can say P bar is equal to Q bar plus R bar, isn't it? P bar minus Q bar is R bar. So, from that you can say P bar is equal to Q bar plus R bar, meaning P bar is the resultant of this Q bar and R bar. Okay. So, here all of them are of equal magnitude. That suggests us so many things. Here in the first problem we have seen, from parallelogram law of vectors, if the magnitude of two vectors is equal, then the magnitude of the resultant is 2p cos theta by 2iz. So, when two vectors are of equal magnitude, then the magnitude of the resultant is 2p cos theta by 2 from parallelogram law of vectors. If theta is equal to 120, resultant is equal to one of them, then R is equal to P is equal to Q. That is what we learn in parallelogram law. Now, let us try to solve that very carefully. P bar is the resultant of Q bar and R bar and all of them, they are of equal magnitude. So, that is possible when Q bar and R bar are at 120 degrees. Then their resultant will be the bisector. That is P bar will be like this and this angle will be 60 degrees, this angle will be 60 degrees. The resultant of two vectors of same magnitude will exactly be along the angular bisector. So, that is what we understood from the problem. Now, look at the question, the ratio of angles between P bar and R bar. So, angle between P bar and R bar is equal to 60 degrees, and P bar and Q bar. P bar and Q bar, this angle is also equal to 60 degrees. That ratio is just 1:1. That is the correct answer for that problem. Okay, I think I am clear. So, here you have to have this concept very thorough. You must be very thorough with the concept. When I am explaining the same problem, look here. When two vectors of same magnitude are at an angle 120 degrees, resultant is equal to one of them. Here all of them, they are of equal magnitude. So, from this expression, P is the resultant of Q bar and B bar, Q bar and R bar. This is the most important thing. So, if all the three are of equal magnitude, resultant exactly lies in between them. So, this is Q bar, this is R bar, angle between them has to be 120. So, P bar R bar angle is 60, P bar Q bar angle is 60. So, ratio is 1:1, right. That is, then let us go to the next question. Look into the next question. See here, the resultant of two forces 2p and root p is root 10p. Find the angle. So, here magnitude of one force is 2p. Magnitude of the other force is given as root 2p. Magnitude of the resultant is given as root 10p. What is the angle between them? This is a straight problem from parallelogram law of vectors. See here, from parallelogram law of vectors, magnitude of the resultant formula is R is equal to root of p square plus q square plus 2pq cos theta. Just to substitute the given data in that formula. So, R is root 10p, squaring on both sides, it becomes 10p square. That is equal to p square, this is 2p whole square, 4p square. Root 2p whole square, that is 2p square, plus 2p is 2p, so 4p, q is root 2p into cos theta. So, here p square, you can just take it as a common factor outside. So, 10 is equal to 4 plus 2 is 6 plus 4 root 2 cos theta. Or if you bring this to this side, 4 is equal to 4 root 2 cos theta. 4 and 4 gets cancelled. Cos theta is equal to 1 by root 2. Cos of which angle is 1 by root 2? Yes, 45 degrees. So, angle between the two vectors is 45 degrees. That is the answer for this problem. So, third option is the right choice for that problem. Now, let us go to the next problem. Look here, this is an interesting question. 11 forces, each equal to 5 Newton, act on a particle simultaneously. Each force makes an angle 30 degrees with the next one. Instead of going to 11 all of a sudden, let us start with this concept. Suppose if there are 3 forces, this is 1, this is 1, this is 1. Okay, all the 3 they are equal in magnitude, and here the angle between one to the next is 90 degrees. Right. So, it is 360 by 3 plus 1. Okay, 360 by 3 plus 1 is 90 degrees. So, in this particular case, what is the resultant? These two vectors are equal and opposite, they just cancel one another. So, resultant is equal to one of them. If we extend the same theory to n equal vectors. N in place of 3 we have n. So, if n equal vectors, vectors of same magnitude, are at an angle 360 by n plus 1 with the next angle between this and this is 90, this and this is 90, like that. So, 360 by n plus 1, then the resultant is equal to one of them. So, when n equal vectors are such that each one makes an angle 360 by n plus 1 with the next one, then the resultant is equal to P. That is the meaning of this statement. Here what is given? 11 equal vectors are at an angle 30 degrees with next and so on. So, this 30 degrees is 360 degrees by 11 plus 1, 12, that is 30. So, exactly this condition is satisfied. So, when n equal vectors are applied simultaneously on a body such that all of them are of equal magnitude and each vector makes an angle 360 degrees by n plus 1 to the next vector, then the resultant is equal to one of them. So, here each vector is 5 Newton, the resultant in that problem is again 5 Newton, that is the answer, right. In the same question, I am going to tell you something. If n equal vectors in the same question, if they are acting such that each vector makes an angle 360 by n instead of n plus 1, then their resultant is equal to 0. Suppose if you apply that to the same concept, if n is equal to 4, then if theta is equal to 360 by n, that is 90 degrees, resultant is equal to 0. For that the proof is so simple. You have 4 vectors like this. Each vector is making 90 degrees with the next vector like this. See, if they are equal and opposite, they cancel each other. These two are equal and opposite, they cancel each other, resultant is 0. So, here we learnt 2 very important points. N equal vectors simultaneously acting on a body are such that each vector makes an angle 360 by n plus 1 with the next vector, resultant is equal to one of them. If each vector makes an angle 360 by n with the next vector, resultant is 0. Okay? So, that is a very important point we should know. Okay, let us go to the next problem. Which of the following sets of forces acting simultaneously on a particle keep it in equilibrium? Suppose if number of forces simultaneously acting on a point keep it in equilibrium, then each force must be the equilibrant of the other. Equilibrant has the same magnitude of the resultant and direction is opposite. So, look here, R bar is equal to, if R bar is equal to P bar plus Q bar, the maximum possible value of the resultant is P plus Q and minimum possible resultant is P minus Q. From parallelogram we have learned that. So, here 3 vectors P, Q, R can keep a point in equilibrium only when each vector is the equilibrant of the remaining 2. So, each vector must have the value lying between maximum and minimum possible resultants. Okay? So, here in the first set is given as 3, 5 and 10. Suppose if this becomes the equilibrant, its magnitude must be less than their sum or greater than their difference. But here the magnitude of the sum is 8, but it is greater. So, very obviously that cannot keep the point in equilibrium. Coming to the next one, 4, 7 and 12. First identify the highest. let us check whether this can become the equilibrant. So, the sum of these two is 11, this is 12 is greater than 11, it cannot be the equilibrant. Now, let us go to the third option, 2, 6 and 5. Let us round off the highest one, 6, and let us check whether that can be the equilibrant. So, the sum of these two is 7, this is obviously less than the sum, it can be the equilibrant, and the difference is 5 minus 3, that is 2. So, the equilibrant of these two can have the magnitude lying between 3 and 7, as this is 6, this pair can keep the point in equilibrium. Again, if you go back to this one, 8, 5 plus 1 is 6, so this cannot keep the point in equilibrium. So, the main concern is equilibrant must have a magnitude which lies between the maximum and minimum possible resultant of the other two. That is, it should lie between P plus Q and P minus Q. Only then all the three together can keep that point in equilibrium. Okay? Now, let us go to the next problem. Look here. So, this problem we are going to see the greater and least resultant of two forces. The greater and least resultant of two forces are 7 and 3. That is, P plus Q is 7, P minus Q is 3. Each of this force is increased by 3 Newton and applied at 60 degrees, the magnitude of the resultant. So, on solving them, just if you add them, 2P is equal to 10, P is equal to 5. So, substituting 5 here, 5 plus Q is 7. So, Q is equal to 7 minus 5, it is 2. Now, P is 5, Q is 2. Each of the force is increased by 3 Newton. So, if this is increased by 3 Newton, it becomes 5. This is increased by 3 Newton, this becomes 8. And then the angle between them is 60. So, now the problem